Day 109 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem, but you already knew what to expect. You knew we would be here. You knew we're not stopping anytime soon. And today we're at day 109, y'all. We're really making some progress here. We're doing all types of problems. Today we have another bit problem like we dealt with yesterday. So that's exciting because that's something new. That's something not everybody sees too much. So you should get excited about that, guys. But before we get started, don't forget, bring your mouse right over here and click that subscribe button. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we could run up this engagement and we could help get this content out to a broader audience and help get more people interested in the Swift programming language as a whole, and we can do our part in helping to build the Swift community and build this community of Swifties around the world, y'all. So with all that being said, I know why you guys are here. And today we have question number 2859, sum of values at indices with k set of bits. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well, because we're all trying to learn here, and there's no point in writing code that nobody understands. Now, with that being said, y'all, let's see what the question says. It says you are given a zero-indexed integer array nums and an integer k. Return the integer that denotes the sum of elements in nums whose corresponding indices have exactly k set bits in their binary representation. The set bits in an integer are the ones present when it is written in binary. For example, the binary representation of 21 is 10101, which has 3 set bits. So what a set bit is, it says the set bit is an integer the set bits in an integer are the ones present in that written and present when it's written in binary, right? So if we write 0 in binary, it's going to look like this, right? If we write 1 in binary, it's going to look like this. It's going to have 1 1. If we write 2 in binary, it's going to look like this with 1 1 as well. We write 3 in binary, that's going to look like this, which has 2 1s. And we write 4 in binary, it's going to look like this, which has 1 1. And what we want to do is, well, let's look at the example. Even though we're at the example, let's go through it from the beginning. So we have the input nums, we have an array of integers 5, 10, 1, 5, 2, and then we also have k, which is equal to 1. What we want to do is we want to find all of the indices that have 1, 1 in their binary representation. So in this example, when we look at 1 looks like this in binary, right? And 1 has 1 1 in its binary representation right here. This is the only one. So that k is good for that. So we're going to hold on to this one right here. This is indice 1 though, not the values. We're looking at the indices right here. Indice 1 has 1 1 in it. Then we're going to come down and look at indice 2, right? Indice 2 also has 1 1 in it. It goes 0 1 0. That has 1 1. So then we're going to come down and look at indice 3. Indice 3 has 0 1s in it. Indice 3 has 2 1s in it, but k only is looking for 1 1. So we're going to skip over 3. Then we're going to come down to 4, index 4. 4 represented in binary looks like this, and it only has 1 1 in it as well. So we have indices 1, 2, and 4 have k equals 1 set of bits in their binary representation. So indices 1, 2, and 4 only have 1 1 in their binary representation, and that's what we're looking for because k equals 1. So hence the answer is nums 1, the answer is nums 1 plus nums 2 plus nums 4, which equals 13. Now, with these, we're adding the values. We're not adding like 1 plus 2 plus 4. We're adding indice 1, 10, plus indice 2, 1, plus indice 4, 2, and 10 plus 1 is going to give us 11, plus 2 is going to give us 13, and that's why our output is 13, because we're finding the indices that have 1, 1 in it, and when written in their binary representation, because k equals 1. So that's why we're only looking for the ones that only have 1, 1. And we could skip over index 0 because it has 0 ones. And we could skip over index 3 because it has 2 ones. We want the ones, binary representations, that only have 1, 1 when dealing with the indices, y'all. Not the values, the indices. So let's look at example 2 just so we can really make this make sense. And it's going to switch up the numbers a little bit. So in example 2, we have input nums equals an array of integers 4, 3, 2, and 1. This time k equals 2. The output is 1. So let's look at the explanation, right? The binary representation of the indices are, so we look at indices 0, indices 0 has 0 ones in it, right? So we could skip, we go over. Indice 1, that only has 1, 1 in it, so we could skip over that. Indice 2 only has 1, 1 in it, so we could skip over that. Indice 3 has 2 ones in it in its binary representation, and that's what we're looking for, the 2 ones in their binary representation, right? So indice 3 is, let's see, 0, 1, 2, 3. Indice 3 is 1, and there's no other indices that have 2 ones in their binary representation. So 1 plus 0 is going to be 1, thus the output is 1. It says only index 3 has k equals 2 set of bits in its binary representation. Hence, the answer is nums 3 equals 1. So remember, guys, the binary representation, we're dealing with the indices, and then once we find those indices that have k equals however many ones k equals, then we add the values of those indices together to get our output. So now that we understand the question, let's get into the solution. It's not that difficult, y'all. It's not that difficult at all, especially if you've been dealing with bits before, and even if you haven't been dealing with bits or binary before, it's still not that difficult to understand, and I'll show you why. So first thing we're going to do is we are going to declare a variable called sum, and we are going to set that equal to 0. Then we're going to come down here and we are going to say nums dot enumerated dot for each. Then we're going to open up our brackets. Excuse me. We're going to open up these brackets and we are going to say, hold on, excuse me, guys. We're going to come over here. We're going to say I, comma, val, because this I is going to represent the index. This val is going to represent the value of that index or the element, because nums enumerated gives us the indice and the value of the indice. So that's why we're using nums enumerated. Then we're going to say I, comma, val, so we can get the index and the value because it's enumerated. Then we're going to say n. Then we're going to come down here and we're going to say if I dot non-zero bit count, excuse me, so this is going to count all of the bits that are not equal to 0, and binary only has zeros and ones, so if it's not equal to 0, that means it has to be a 1. So we are going to set that, say if that's equal to k, then what we are going to do is we are going to say sum plus equals val, because we want to add the vowels together, the values together, right? Not the indexes. So this I is going to see if this index non-zero bit count is equal. It's going to count the ones and see if they equal k. And if they do equal k, then we're going to add the values together or to sum, and we're going to continue on until we add up all the values. Then we're going to come down here and we are going to say return sum. And that should be all she wrote, y'all. So let's run it and see how it runs. Told you it's not that difficult, y'all. Not that difficult at all as far as the solution. Easy to understand because it's basically right here, the non-zero bit count. It has to be, so it's going to count the ones, the integers that aren't 0. So now that we see it's accepted, let's submit it. See how it runs. And it's accepted, y'all. That's why I like to see 25 milliseconds beats 42.31% of users with Swift, y'all. That's what I like to see. I hope y'all learned something today. I feel like the trickiest part of this question is you just have to understand that we are looking for the binary representation of the indexes and not the values. We're looking for the index and then we're adding the values together. So if k equals 1, we want to find the 1 and index 1. This is index 1. This is index 2. This is index 3. This is index 4. It's not the values, it's the indexes. And then once we get the indexes that we need, then we add those values together, guys. And I feel like that might be what confuses people the most. So I just wanted to reiterate that. Now get one more look at the code, and I'll see y'all tomorrow for another day, another LeetCode problem. Peace.